Hello, my name is Brad Hollister, and I am currently a student in the Software Engineering Doctoral Program. I'll be talking today about the system design and implementation of a casual game recently developed at my company, Light Matter Software, LLC. The game is currently for sale in the Android marketplace. Here we have the Level 2 component and connector diagram, showing a high-level organization of a subroutine-based architecture for the game. The primary component is the game main update loop. It communicates with the various subroutine components via procedure call based connectors. Since the application that is being described is a real time game simulation, the app maintains various game objects. These objects specifically are the redirection walls, mines, gold coins, and the player character. In this architecture, these game objects are held in globally accessible list data structures, and the various subroutines perform their respective tasks of checking for collisions, updating positions, game state, and drawing the entities. This should be immediately obvious from the provided diagram. The five subroutine components game main update loop, get user input, draw game entities, and check for collisions are included in the model to implementation diagram. The subroutine architecture was implemented as part of the prototyping implementation phase of this project. Therefore, a specific mapping from these subroutine components to exact C functions is available and displayed in this table. As can be seen, some of the components map to more than one subroutine. This is the case for the draw game entities component, where it maps three separate functions in this diagram. The following slide maps the remaining prototype implementation functions to the subroutine component diagram. This diagram shows the remaining mappings that the previous diagram did not show and completes the entire mapping for the prototype implementation to the level 2 component model diagram. This slide shows the initial design component connector diagram for the object-oriented style of the game program. We have the following 7 components: game application, game grid, mine entity manager, mine entity, gold piece entity, gold piece manager, and game player character. The connectors are once again component interface procedure calls. As will be seen, the components map nicely to the classes in the actual implementation. This UML class diagram was generated from the source code using Argo UML. However, it was preconceived from the beginning and follows the component level organization closely. Because of the use of OpenGL ES, a utility class called SmallGlut was written, from which all drawable game objects were derived. The game manager classes, including the class game application, can be seen as separate classes with no inheritance. It should be noted, though, that Game Application and Start Screen were both derived from the Android SDK Framework Activity class. All activity-derived classes represent distinct screens views in an Android application. The table here shows the mapping between the object-oriented style architecture and the actual class diagram implementation. The components lie leftmost in each row, and the implemented classes are represented in the column headers. All the components map to representative classes. However, the redirection wall class did not have representation in the original component diagram. This table completes the mapping. Again, all components map to representative classes. Because of the particular nature of the Android SDK, the start screen and the Vec2 classes were not planned for in the original component architecture. This slide contains the pros and cons aspects of the subroutine-based architecture that was first considered for the game application. The C language was used for the prototyping and is a procedural language by nature. It provides for high-speed hardware-specific compilation, but generally the code is harder to maintain and read. It does not scale well either. Many mobile platforms, in order to reduce overhead, use C or assembly, and because of this, many mobile platforms are constrained to subroutine-based software architectures. This is not the case with Android-based mobile and embedded devices. This table shows the pros and cons for the second architectural option for this project. Here we look at the object-oriented style in particular. Speed of execution varies, but with Java, the JVM is considerably slower than a hardware-specific compilation. But this architecture is much more extensible, even if it is not easily written for smaller programs. The second architecture was selected for this project. The Android platform requires the use of Java, and Java is an object-oriented language that easily implements an object-oriented software architectural style. This slide shows a successful compilation of the project code. There are some warnings, but the APK file from the Android Marketplace is sufficient to prove compilation and use. This slide contains a short video demonstration of the project code. And I will now, in addition to the video that is already posted on YouTube for the demonstration of the project, I will demonstrate it as part of the single video file. Here I have the Eclipse IDE with the project loaded. And in the left pane, you can see the classes of the CoinRage project. And it's already been launched in the emulator, so I'll pull up the emulator. And the beginning activity screen is showing here, and we'll start the game. And it's running a little bit more slowly than normal, but it seems to be running pretty fast since we're recording audio and video at the same time. These two buttons down here provide these walls that redirect the player at 90-degree angles. And as you can see, the player will bounce from that wall. And the object is to intersect with the coins and to not intersect with the bombs. And as you can see, there is a score and a lives displayed at the top of the screen, which record the number of times the player dies and the score, the number of coins that the player picks up. And redirect the player around. And he just died, and he just died again, and then he picked up a coin. And if we go back to the home screen, we can see the icon here. And as you can see, that starts up the game, back to the beginning activity screen. So that's it for the project presentation, and I hope you enjoyed it.